Alright, part two of the video. Sorry about speeding through this last one. As I told you before, I'm a little confined with time with this app I'm using. Just to reiterate a couple things, we want to make sure we have a side-side angle relationship in order to be able to use this. You're always going to be using law of sines. Now, this procedure you do not need to follow. The biggest one that you need to focus on is obviously the one that's down in red down here. So we're going to take height is equal to the opposite side. The side not opposite the angle x. So the angle I'm giving you and the sine of the given angle. So B is the side that I'm providing you that's not opposite this angle, and then this is the angle provided. And that angle here will always be acute. If it's not an acute angle, we're not even going to have an ambiguous case, and that's why this whole question up here is asked. So you kind of don't have to do this whole procedure, but if you check to make sure, hey, I've got a side-side angle relationship, I've got a given angle that's acute, and then my height is the smallest of the three sides, of the side that's opposite and the side of the angle that's given, you're going to have two cases. So nice visual for what's going on here is that in the side-side angle, these are your choices that you have. First of all, if that angle is acute, here's your four options. You either have none, you have one, or you have two. The key one is right here. This is the only one that has the two triangle case. And that's because the side that's across from the angle is less than the given one. Where here, A is larger than B, then you automatically have one triangle. If A is equal to the H, which is B sine of A, then you have a right triangle. It's acute. They're equal. Same proportion. Same thing here. If A is less than B, we don't have a triangle because there's no way that this little pivot arm here is ever going to connect with the bottom length. So the one case we worry about, it's acute. A is the greater or less than B, but it's greater than H. So this is what I said. If H is the smallest value out of everything that's given to you, you have two triangles. Now you're probably wondering, how do we find these two triangles? So let's just kind of do an example here and walk through one. I think once you guys see an example or two, things should kind of fall into place. All right, so I mean, a lot of this is just going to be the setup because I expect you know how to do the law of sines and how to solve the proportion. It's just getting to the second angle measure, which is going to be the key. So let's do an example. And feel free, like at any point, you need to pause this to copy some things down to make sure you have this visually taken care of. Feel free. Obviously, this is at your pace. So let's go. Let's solve the triangle here. Let's round the answers to the 10th place and the side lengths to the 100th place. So the first thing that I'm going to tell you right now is let's just draw pictures. So we've got picture could look something like that. We'll say 50 degrees is here, 5 is there, 6 is there. So our criteria first, we need to make sure, is this given acute angle? This is an acute measure. So check. So right now, we've eliminated obtuse, and we're only focused on these four values. And then we want to check to make sure, is the side that's not given greater than or less than the side across from the angle? So since B is greater than 50, in other words, B, is greater than A, we're going to go back to our cases here. And since B is greater than A and we have an acute angle, B is greater than A, we either have two triangles, either two triangles, one triangle, or none. So we've done that. We checked that part. We're given a side-side angle relationship, so two S's and an angle. So now let's go ahead and calculate our height. Let's find the height of this triangle, what we're looking for there. And to find that height, we take 6 times the sine of 50 degrees. So it's the angle that's not across from the given side. So we take this 6 and we multiply it by the sine of that. And when you do that, you get H is equal to 6 sine of 50, which is 4.59. We'll go 4.5963. So we do our analyzing step. B is greater than A. B greater than A. All right, and then we go back and we realize that H is B is greater than A, and is A, so B is greater than A, is A greater than H. And since 5 is greater than 4.59, we now means we have a two triangle case where we have this B is going to be either an acute angle or it's going to be obtuse because we don't know where this 5 is swinging. So to calculate that, you do the exact same thing we've done before. We go sine of 50 over 5 is equal to sine of B over 6. And now we cross multiply. So we got 5 sine of B is equal to 6 sine of 50, which by the way should look familiar. 6 sine of 50, 6 sine of 50. That's where the whole height is coming from, the formula of law of sines. Divide by 5, and you should get sine of B is equal to, let me just punch in the calculator here, 0.9193. And a little reminder from previous chapters, we know that when we're taking an inverse with sine, that your domain has to be between -1 and 1. So that value for x, or that angle that you're looking for, that you're doing the inverse of, has to be between those two. This is a good value. It's less than 1, greater than -1, therefore we can take the inverse. And when you take the inverse of that answer, we get an angle measure of B equaling 66.8 degrees. That is this angle right here, 66.8. And then we go ahead and find measure of angle C, because these three have to add up to 180. We take 180 minus 50 minus 66.8, and we get a leftover of 63.2. I'm going to go ahead and get this picture out of the way here for a minute. And then we do law of sines again. So we're right back to the two scenarios. Sine of that angle, 63.2, all over C is equal to sine of 50 all over 5. Cross multiply, find the value of C. We get 5 sine of 63.2 divided by sine of 50, and we get 5.8. 5.83. That's the value for triangle 1. So that's what you did on the past worksheet where you didn't have any ambiguous cases. So now in order to get our ambiguous case, our second triangle, because based on the information we don't know what kind of triangle we have, we need to create a second scenario for all of these spots, because to find your second one, you just take 180 minus this reference angle that you basically found of 66.8. 180 minus 66.8 gives you 113.2. This is our second triangle. And this should kind of now make the 6 the largest segment. So before, on this case, 6 was the largest because this was the biggest angle, but now it should be even farther away from side length A and side length C. This value here we're going to end up finding is going to be a little different. So now that you found the second one, we just take this angle plus the 50 degrees and we subtract that from 180. So 180 minus 50 minus 113.2 is 16.8. So triangle 1 is in purple. Triangle 2, that special case, 113.2, 16.8, and 50, now gives us another law of sines, but we're going to go sine of 16.8 over C is equal to sine of 50 all over 5. Make sure we always reference back to that original one. So we go 5 sine of 16.8 divided by the sine of 50. And we're going to get a value for C that's equal to 1.89. That is your second triangle. So 1.89, 6, and 5 that's the obtuse triangle, where the purple one is the acute. And we had that second one because this was true. The height was the smallest value given in A and B based on the given side length. These three things will never change in your triangles. These are what you're calculating. So in a way, you're doing law of sines once, twice for the triangle 1, and you got to do it for triangle 3 after you find your second angle. So let's go ahead and do another one. I'd like you guys to try this one first, and then let's do it. All right, so a couple things is acute angle. All right, so let's just draw our triangle here quick. We'll go 70 degrees. Across from that is 6. Across from that is 5. So the first thing we want to make sure is, do we have an acute angle? Yes. It's acute. Check. Second thing we want to check is the side opposite, going back, is the side opposite B, is that greater than A? Is this value here greater than this value? If this is not greater than that, we do not have an ambiguous case because B is not greater than A. All right, so right now in this situation, we have the angle given to us, 6, is greater than B. So if we want to go ahead, we can find our height. Height is equal to 5 sine of 70. 5 times the sine of 70 gives us the height of 4.698. So is the given value x, the side opposite is going to be my B value. So since this is not greater than that, since B is not greater than A, I don't have two triangles. And since A is less than H, if we look here, A is greater than H, so we have a triangle. In fact, then we're going to have, oops, sorry, here, I'll skip the page. So A was bigger than H, so that doesn't true. A is greater than B, A is greater than B. Well, it's an acute angle. A is greater than or equal to B, therefore, in this case, we're only going to have one triangle. You didn't meet the requirement that this non-side that doesn't have an angle is not greater than this. So therefore, you will not have a second case, even though you have a side-side angle relationship. So now we just solve like we normally would. Sine of 70 over 6 equals sine of x over 5. And then we cross multiply. So when you cross multiply, we get sine of x is equal to 0.7831. So therefore the measure of angle x, when you take the sine inverse, we're going to get 51.5 degrees. So that's going to be here. And then you subtract that from 180 to find the measure of angle z. And then again, we would then do sine of, let's see, 180 minus, you get 58 for z, 58.46. So we're going to go sine of 58.46 all over z is equal to sine of 70 over 6. And we cross multiply. We should realize that this z value needs to be smaller than 6, but it has to be greater than 5 because of the angle measure. Bigger the angle, bigger the side, bigger the angle, bigger the side. So I'll leave that one up to you when you solve that one. So just keep in mind, the key thing is just always find your height right away. Just that way you can figure out to see if you have a second case. Plus, this height's going to be helpful when we look forward to moving forward here with area of oblique triangles.